There's a planet 41 light-years from Earth where one side is permanently on fire. Its surface is a churning ocean of liquid rock. A year lasts just 18 hours. And somehow, against everything we thought we knew, this planet has an atmosphere. The James Webb Space Telescope just confirmed it, and it changes everything about how we search for life beyond our solar system. Let me tell you about 55 Cancri, also known as Janssen, and why this scorching ball of magma might be one of the most important discoveries Webb has ever made. So here's the setup. 55 Cancri orbits a sun-like star in the constellation Cancer. It's one of 5 planets in that system, and it's the innermost one, orbiting just 1.4 million miles from its star. To put that in perspective, Mercury sits 25 times farther from our Sun. This planet is so close that its star would appear 70 times wider in the sky than the Sun does from Earth. It's classified as a super-Earth, meaning it's rocky like our planet, but bigger, about twice Earth's diameter and roughly 8 times its mass. Because it's so close to its star, the dayside is absolutely scorching. We're talking temperatures that should hit around 4,000 degrees Fahrenheit if there were nothing but bare molten rock of graphite and diamonds. And the planet is almost certainly tidally locked, so one side permanently faces the star while the other sits in endless darkness. Now here's where it gets wild. When a team led by Renew who at NASA's Jet Propulsion Laboratory pointed Webb's infrared instruments at this planet, they expected to see those blazing hot temperatures from the dayside. Instead, the measurements came back at about 2,800 degrees Fahrenheit, roughly 1,200 degrees cooler than predicted. That gap is massive, and it tells scientists something crucial. Energy is being moved from the dayside to the night side. The most likely explanation? A substantial atmosphere. The team used a technique called secondary eclipse spectroscopy. Basically, Webb measured the brightness of the star when 55 Cancri was behind it, starlight only, and then measured again when the planet was beside the star, capturing the combined light. The difference between those two readings revealed the infrared light coming from the planet's dayside, and the spectrum didn't match a bare lava world. It matched a planet wrapped in a volatile-rich atmosphere, likely containing carbon dioxide or carbon monoxide. But wait, if the planet is this close to its star, getting hammered by radiation and stellar winds, how does it hold on to any atmosphere at all? That's the really fascinating part. The team believes this is a secondary atmosphere. The planet's original atmosphere, hydrogen and helium from when the system formed, was stripped away long ago by the intense radiation. What Webb detected is a replacement atmosphere, continuously belched out by the planet's own magma ocean. Dissolved gases trapped in the molten rock are constantly bubbling to the surface and escaping, essentially giving the planet a brand new gaseous envelope in real time. This matters far beyond one extreme planet. Earth itself went through a magma ocean phase billions of years ago. Studying how 55 Cancri generates and sustains an atmosphere from volcanic outgassing could give us direct clues about what early Earth, Venus, and Mars looked like during their most violent chapters. As Renew put it, understanding the conditions that allow a rocky planet to maintain an atmosphere is the key ingredient for identifying habitable worlds. And this finding proves that Webb can actually do that kind of science on rocky exoplanets orbiting sun-like stars, which is exactly the type of system where we'd look for another Earth. 55 Cancri won't host life. Its surface is literal lava, but it just became one of the most valuable laboratories in the galaxy for understanding which rocky planets can hold onto an atmosphere and which ones can't. If this discovery caught your attention, drop a like and subscribe so you don't miss the next breakthrough from Webb. And tell me in the comments, do you think we'll find a habitable rocky planet with an atmosphere in the next decade? I want to hear your predictions.